Hi guys, welcome back to the EXPLIoT video series. My name is Apar and I'm an IoT security bandit at EXPLIoT. So in today's video, I'll be covering the dicom plugins. Dicom, which basically stands for Digital Imaging and Communication in Medicine, is a standard form of communication for acquiring, transferring, and storing medical images and related data between different medical devices. These medical devices include your MRI scan machines, your ultrasound machines, and so on. So by now you would have already figured out that it is widely used in medicine and healthcare industries. So I'm already assuming that you know about dicom. If not, I first suggest you to check out what dicom is and then return back to the video. So as for the EXPLIoT framework, it has three plugins for dicom: the CFind, the C-echo, and the C-store. So in this video, I'll be covering two plugins, which is the CFind and C-echo. The third plugin, which is a C-store, has some implementation issues. So if you are someone who has worked on dicom before and would love to contribute to the EXPLIoT framework, I suggest you to get in touch with us via our EXPLIoT framework official project repository on the GitLab. So as for the setup for this demonstration, I'll be using a test server which is available on www.dicomserver.co.uk. So I'll be using this server as a service class provider, and it listens to port 104 and 11112. Apart from that, it has a sample data set on which I can run my CFind queries. So the link is on the page itself, and it has a link where it keeps the log of the server. So before I begin with this video, I have a small request. Kindly do not indulge into any kind of DOSing or malicious practices with such test servers, because these servers are set up for us, for the community, in order to learn more about these protocols. Alright. So now let's fire up our EXPLIoT framework. So the first plugin that I'm going to show you is the C-echo, and the plugin ID for the same is dicom.generic.c-echo. -H for the specific help. So this test case sends a C-echo command, which basically attempts to associate with the dicom server, which is the SCP in our case, the service class provider, and checks if we get a response from the server. It is a good way to identify if the server is running and we can connect to it, which is obviously our first step in pen testing dicom. So there are a few arguments that we have to take care of. The first one is -r, the R host. It is the host name or the IP address of the target dicom server, which in our case is the dicomserver.co.uk. So I'll simply copy this. Next is a -p, which is the R port, the port number of the target dicom server. Default is 104, so we'll be using the default port. Alright. Next is -c, which is AET SCU, which basically means AET of the SCU. AET is the application entity title, or in layman's term you can call it name of SCU, service class user, or the client. So it is basically the name of the client that you have to put in this argument. The calling AET, which can be either your client or the exploit. Default is any SCU string. Alright. Next is -s, which is the AET of the SCP, again name of the service provider, the called AET, the dicom service. In this case, the default is any SCP string. Alright. So this can be any SCP string or any other modality such as ultrasound, CT, RF, or likewise. So let's quickly run this. So we'll be using the default port, so no need to enter -p. See, let's say our client is EXPLIoT, our service class provider is something like ultrasound, so US. So as you can see, it has attempted to connect to the dicom server, which was present at dicomserver.co.uk on port 104. So our calling AET was exploitive, and it called the ultrasound which we gave. You can give any other string as well. Alright, so it gives out the version number of the server implementation, the class UID, and the response status. So you can see the test dicom has passed, dicom.generic.c-echo has passed. So it basically means we were able to establish a connection with the dicom server. So now moving on, our next plugin is the CFind, which is, as the name suggests, basically a query that you can run on the dicom server in order to get or fetch any data. -h for the specific help. This test case sends a CFind message, which is a query for a patient name to dicom server, which is the SCP in our case, and shows the retrieve details. Pretty simple, right? So the options, the optional arguments, the arguments are pretty much the same. First is the our host, which is the host name or the IP address. Next is -p, which is the port number. So we are using default port 104. Next is -q, which if specified you have, this uses as a source or the local port number for the exploit. So I suggest you to put any port number more than 1023, so you don't need super user privileges. Next is -n, the name. Specify the patient name to search. You can use wildcards like a star or a question mark, as mentioned in this given link. So these wildcards are basically if you want to retrieve more than one patient names. Alright. Next is -c, which is the AET of the SCU, which is again the client name. Default is any SCU string. Next is -s, which is the AET of the SCP, which is dicom server in our case. Default is any SCP string. The last argument is the -m, which is the model. Specify the information model to use for the CFind. So as you know, there are a lot of variants for CFinds. So these options are P for patient root, S for study root, W for modality work list, and O for patient study only, which is not in use now, it has been discontinued, and the default is patient root. So these are different types of information model to use for CFind. So for example, patient module has things like patient name or the ID. Likewise, for the study root, you have things like study UID, study date, and so on and so forth. So let's quickly run this as well. CFind -r, let's put dicom-server.co.uk. Our port number, let's put 1500. The name we want to search, so let's search for John. Alright, Jones John. So you can see he has done, the patient Jones John has done tests for two different modalities, which is the CT and the MR. So let's search Jones. Yeah. So next is -c, which is EXPLIoT. -s. Let's not put anything right now in -s. M, since we are using patient root for this demonstration, so I won't put this argument as well. So as you can see, it has retrieved our patient, which is Jones John, and it basically the dicom separates the name using these. Now let's run it in order to search for different modalities. -r, so basically this, we want to search for all the patients that have used the modality. Which one? Let's take any modality, for example, who have done MR. Alright, so as you can see in the name, I have put a star, and in -s, which is the service, which is basically a service class provider, I have used MR. So it should give me a list of all those patients who have used MR modality. So as you can see, we have got the list of all the patients that have used the MR modality, and our test has successfully passed. So that was it for this video. I have shown you the C-echo and the CFind plugins, the dicom plugins of the EXPLIoT framework. For more details about EXPLIoT, you can log on to our website, which is www.exploit.io. You can shop for the cool hardware that I'll be showing in the coming videos. To refer to the documentation, you can head on to exploit.readthedocs.io. You can follow us on Facebook, Twitter and LinkedIn. The links are on the screen right now. So if you like the video, you can press the like button, you can put a good comment, and apart from that, you can subscribe to our channel. So this basically helps us and motivates us to put up more good IoT security related content for you guys. So that was it for this video. Thank you guys. See you in the next.